In this lesson, we're going to be talking about the surface area of right prisms. To find the surface area of a prism, so this is any prism, you need to find the sum of all the areas of each face of the prism. To help with this, it's useful to draw a net of the shape to show all surfaces of the solid. Here's an example of a prism in an ice cream sandwich. Hope you don't get too hungry. So there's a couple of steps for finding the surface area of right prisms. So the first is to either visualize the surfaces of the solid, but if you're struggling to do that, then just draw a net of the solid. So we're going to do that in one of the examples. Once you do that, you need to write a formula for the surface area using step 1 as a guide. So it will be different every time, and you need to use that net or the visualization of the surfaces in order to figure out exactly what that formula will look like. Once you have your formulas, you need to substitute the values into the formula for the surface area, and then use your calculator to find it, and then answer with the correct units. So for our first example, we're going to find the surface area of this rectangular prism. So you can see it's got a length of 8 centimeters at the front, and the depth is 4 centimeters, and the height is 2 centimeters. So the surface area for this, and we're going to draw a picture for this as a net, you can see that it's made up of 6 rectangles. So there's going to be 2 rectangles that look like this, which is one's here and one's here. We have 2 that look like this. There's one here and there's one here. And then there's 2 that look like this. There's one here and here. So we're going to have 2 lots of one rectangle, 2 lots of another rectangle, and 2 lots of a third rectangle. So when we substitute some values in, we need to make sure that, let's say this rectangle here, we have 2 lots of 8 times 4. We have 2 lots of 4 times 2. So there's the 4 and there's the 2. And 2 lots of 8 times 2. A neat little trick for this, you can see that we have 8 mentioned twice, we have 4 mentioned twice, and we have 2 mentioned twice. Now we're not going to worry about these lots of 2's because that's only there because there are 2 lots of each of those rectangles. So if you have 2 of each type when you're working with a rectangular prism, you know you've done it correctly, and in the end, if you type that into your calculator, you get 112 centimeters squared. So that is, of course, the surface area. Moving on to another example, we've got a triangular prism. So to find this, you can either draw a net. For this one, we're just going to visualize it. So we've got 2 lots of a triangle. So you can see that there's a triangle here, and there's that same triangle here. And then we have 3 rectangles. So there's rectangle 1, which could be this big one here. So we can see there's 1, 2, 3, 4 corners of that rectangle. And then you could also consider that there is one here. You've got corner here, 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 and here of this rectangle. And then there's the base rectangle, which is this here. So using those corners to kind of visualize that. So with the triangle, we know that the formula for a triangle is half base times height. And then the rectangles are just one side times the other. So when we substitute some values in, so we've got 2 lots of this triangle. So there's a half times a base of 8 times the height of 6, which is where that comes from. And then we've got this rectangle, which is 10 by 10. And then we've got this one, which is 10 by 6. And then the base, which is 10 in this distance by 8. And when we type that into the calculator, we end up getting 288 millimeters squared, which is, of course, the surface area. Now, you'll notice that there is a lot of working in these questions. If you don't like writing them in this one line, that's fine. If you want to, you can say, well, the triangle is this area, and the rectangle 1 is this area, and so on and so forth, and then add it all together at the end. That's fine. This is just a different way of doing it. Okay, so our final example is to find the surface area of this trapezoidal prism. So we can see here that there's a lot of stuff going on, but really it's just 2 trapeziums, and then there's all these different rectangles. So there's this one at the top, one at the bottom, and one on either side. Okay, so we'll start off by considering that that's this surface area. The surface area will be 2 lots of the trapezium, and then the sum of all those rectangles. So we're adding them all together. So there's going to be a lot of working out here, but it's okay. We'll just take it one step at a time, and you'll see if you break it down to parts, it's a bit easier. So this first part here is the trapezium. So there's 2 lots of the trapezium, and if you remember from last lesson, we went over the formula to find the area of a trapezium, which is h on 2 times a plus b. In this case, I've written half times a plus b, and then times it by the height. That's the same, it's just written a bit differently, just so you can see that there's different ways to solve for the same thing. So I've substituted in half from the formula, 2 because there's 2 trapeziums, a plus b, so 18's the base, like the bottom, and then 11's the top, so that's why it's a, like that's the a and that's the b, and then the height we can see is 6 centimeters, so that's where that comes from. Then we've got 4 rectangles. So there's 11 times the 16, which of course 16's there, but that's the same as this length, so that's 11 times 16. And then we've got 7.7 times 16 plus 18 times 16, which is that base rectangle there. And then there's a 6.4, which is this length, times the 16, which is that length there. And when you type them all into the calculator, you can, as I said, you can do it in parts. So you would do everything between the brackets in one go and then add them all together at the end, or you can just do it in one big line, and then you get 863.6 centimeters squared, which is the surface area. So that's all for this lesson. We're going to move on to cylinders and spheres next lesson, and I'll talk to you then.